Need to share screen. Go .cpp. I think this one works too. Okay. Awesome. Okay, so let's get started. So this one, I basically will sacrifice all your challenges for PA for LE0 and LE1 to tell you exactly what you need to do. LE1 to tell LE1 to tell you exactly how you use GDB. So people who actually run this will encounter the memcpy problem. And let's me run it and see what happened. Okay. So let's run. So how do you run this? Well, first you do make, right? You cd into, make sure you're in the working environment, make, okay, and that will compile for you. And one more thing I forgot. So in .g, right? You want to add the dash the G flag because it will help you debug. Without this flag, there's security issue that if you don't add this flag, it will randomize the address space, and then GDB wouldn't be able to read the address space. So add the G flag will not randomize the address space, and you're allowed to see exactly what line is a problem. So add a G flag right there. So you can type make, of course, once you do make, okay, and with the G flag do make. And now let's run it and see what happened. Okay, what source slash? Oh my God, look at that errors already. This does look scary, but once you actually read it, like, you know, another, like a person. If you once you read it, you will see that it's actually not that scary, because first of all, you see this red thing and you're like, oh my God, it's just segfault. That's it. It's like 00 address 000. Okay, ignore that. The signal is caused by read memory access issue. So there's probably something is reading something that it should not be reading, right? So then you go to here, you go down a little bit, and address point to 0 page. That is the first hint. It's pointing to something with the word 0 in it. And you know when something is 0, something is wrong. Or, you know, it might be wrong. So now you go down even further. This whole, you see the numbering on the right, on the left rather, you see 0, 1, 2, 3, right? That is the representation of the stack. Okay, of the whole executing the program. So then if you read, ignore 3 and 2, you don't need it. But if you look at 1, it said in line 67, something happened, okay? So this is only, you know, once you add this G flag, it will tell you exactly what it is. So in line 67, what happened? Add points right here, okay? So this add point function is called. And then in line 33, oh wait, that is within the function. It yelled you, there's something error in line 33, and that is memcpy. Okay. So so once you identify what it is, right? It's very cool that it's built in already yelling at you if there's a memory problem right here. You can start GDB and go in and start investigating. Okay. So, you know, with normal people, with normally what you would do, I assume is that you would do print, right? You try to print things like print this, print that, and then see where the problem is, right? But GDB, being GDB, is very good at telling you what exactly it is. So GDB, and you type the executable GDB buggy, enter. Okay, so it's in this screen, right? So you can type. Okay, so to be able to run in GDB, you just type R or run. This works too, right? You type run, and it yelled you again. Line 33, there's a problem. Okay, so your goal is, you think about this. If a program executes from top to bottom, right? Then it's probably going for, then anything above line 33 probably work just fine, right? And you know, not including the main too, because you go to main and it calls the function, right? Bless you. So in line 33, this happened. So anything before that probably worked just fine. So to be able to investigate, so you want your program to just execute everything up until the point it breaks. Okay. So how do you do that? You use something called a breakpoint. So let's say it yelled you line 33. So you want to execute everything before line 33. You can type break or B, that works too. Break, and you type and you enter and you line you want to break. So line 33. So when this happened, what happened is it will execute everything below line 33. It does not execute line 33. So let's run it again. So run it again, just type run, and tell me to type yes. Okay, so you see it tell you right here, breakpoint 1. You enter that breakpoint. That means it's execute before everything before that, but not that. Okay, so line 33, you see that if you look closer in line 33, you see it's memcpy, points I, then you have a bunch of parameters within memcpy. So the first thing I always do is understand what it does. What does this line do? Okay, so you can go to you open a new terminal by pressing plus. Let me plus right here. Okay, and for a lot of functions within Linux programming, there is a very powerful tool called man, M-A-N, man stands for manual, and you can type man, and you type man, and then you type the function do you want to understand. So man copy, it will tell you a dictionary. It will show you a dictionary of like definition of everything that you need to learn about memcpy. So name, memcpy, copy memory area. Okay, it will tell you exactly what you need to include. String.h. Some people said C string works too. So C string is a C++ library, while string.h is a C library. And Linux is written in C. So a lot of these man page asks you to import C libraries. Okay, so include string.h, and it'll tell you exactly what the parameters mean. It will return a void pointer, which means whatever pointer it wants, and then it said destination right here, void source right here. So the first parameter is the destination, the second parameter is src or source, and the third is n, right? And you read the description literally. The memcpy function copies n bytes from memory area source to memory area destination. So it just moves. It's like, you move from one house to another, you would U-haul. So this is like, you can think memcpy is the little U-haul action right here. Okay, so good until this point. Okay, so let's go back. Okay, so now if you look in here, so you have point I as your destination, right? And then your n% points whatsoever as your source. So it will, and size of point. So basically we'll move points from the parameter, the function parameter. Let me scroll down here a little bit. From the function parameters here into the points I of the member, right? Does it make sense until this point? Okay. Okay. So what you do now is you want, if it's a sec fault problem, it's probably something to do with memory, right? So this is where the magic happened. You can do print. So if you want to see what exactly is in a variable, you can type print, and then you can highlight the variable you want to see. Okay, let's say you want to see points, right? What's inside the points to see what, enter. Oh my God, it will tell you exactly it's in it. X is equals 0, Y equals 0. It's on you the first point, right? Oh my God, so now you don't have to do cout to see the thing anymore. You just do print, and it works. Okay, and then let's do print. So this one looks fine. If you look at the address, you can also do the address too by just adding the ampersand in front of it. Oh my God, it tells you exact address. It looks fine, right? It doesn't seem like an illegal memory address as of right now. Okay, so now let's print the other one. So let's print point I and see what's in it. So point I is now a pointer. Oh my God, you see that? You see, it said 0xBEBEBEBE. Something is probably wrong here, because why is it all BE, right? Like, it's something's wrong with this memory address, because most memory addresses probably randomized by IP address. Why is this so perfectly BE? So what I usually do is, if I see a sus pointer like this, I just go in and I just go to Chrome. Okay. Oh, they probably can't see Chrome, but you go to Chrome. Okay, for people on recording, go to Chrome and search BE. Okay. And you see, okay, member access within misaligned, blah, blah, blah. I don't care. Just see Stack Overflow. You click on the first link. I don't care about the question ever. I just look, and let's see. This mainly happened with this code because you are not initializing left and right pointers of the node properly. They are set to null. That is the important part. They are set to null. And remember, when you start with the address sanitizer, remember the word 0 page? So you are basically accessing something that is null, right? So imagine if you move from a house, your old house, to your new house, and you move, so basically you move your old house, which is already built, to a null house, which is not there, well, that would cause problem, right? Right? So at this point, does anyone like, so good? At this point, y'all got it? Okay. So this just means that you're moving from this point into a null pointer. Okay. So can anyone know why this is a null pointer? Like why points I or any points? And actually, you can also do print. You don't have to do point I, you can do point 1. Okay, it's a null pointer. Point 2, that's a null pointer. 3. Oh. 3, that's a null pointer. So why is why is the array all null? Yes.
It was initialized to be an array of pointers, but it had no the pointers weren't pointing anything.
There you go. So you initialize points, right? You initialize point right here. I mean, you initialize the array of points right here. That means you built the street. It's like you built the street, but you never built the house, right? So you built the street right here, but you never built the house. So you have to build the house first before you can move in, right? So well, how are you going to do it? Well, I know you know, but anyone knows how to build the house in this case, or build an construct the object? Huh? Yes. So loop through all the empty lot, right? Empty lots and build the house. But how do you build it? How do you build an object? New, right? Okay. So it just what you loop through the house, each lot, right? Points I. And you do equal. But okay, equal what? Tell me. New. Okay. Anyone else besides two brilliant people here? Point. So make sure. Oh, some people forgot to do parentheses. You just point. You're referencing a object. I mean, the blueprint, and not calling the constructor. So okay. So that seems like it. So how do you quit GDB? So that seems like you probably find the answer to the problem. Just press quit or Q or quit. Yes. And then you do make again to see the changes. So now let's run. Okay. So this is a bunch of leaks. It's telling you there's a bunch of leaks. That's okay. But if you go on top, there you go. You fix it. Okay, so there's now a bunch of memory leaks, which now we will show you how to do memory leaks. Okay. So if you have a memory leaks, what does that mean? Does anyone know what a memory leak is? Remind yourself what a memory leak is. Yes, right? Manually, right? You use the word new for every, you could think of it as like conservation of memory. Like if for every new, there should be a delete, right? So so that means you probably have to call the constructor, right? You have to implement in the constructor. So let's look at the problem. Let's look at the error. So the first one said, okay, so you always look at the top one. The top one is usually tell you. So this one is ascend, which is something else. Don't worry about it. But right below it, it said line 22. So let's go to line 22. Oh my God, right here. You initialize the street or the array of points, right? But you never delete the points. So let's go and delete it. But for an array, you can do, most people would think you do this, right? Points. But remember, this is an array. And it tells you exactly there's a new, in the new, there's a square bracket next to the new. Okay? That means that probably signals that you also need a square bracket when you delete points like this. Does that make sense? So when you delete an array initially, when you delete the manually allocated array, you want to add the delete, you want to add a square bracket in. And that seems to be a very common error too. So people tend to just ask us like, wait, why this is yelling at me for mismatch square root, square? It just probably means they try to delete an array without the square brackets. That's it. Okay, so that's okay. So that's the first one. We conquered the first one. You can see that the second one is just the same one. So let's skip that one because it's the same line. But if you go to the next one, you say line 49. Okay, so let's go to line 49. What happened down here? Oh my God. Okay, so you see the new right here. Okay, and this is literally how you also solve. You probably saw the problem with the function yelling at you for something like dereferencing, and you got crashed at this point. Yes. Yes. I'll get to that. Okay. So you see this. So this is how you solve it. So does anyone have encountered this problem where if you run this original code without this whole thing, it would yell at you? Anyone try to run it? And you see that, hey, it's like, it looks normal at first, and then you realize it's this blew up. It's because with the function, if you remember from 121, they taught you that when it comes to locality, when you call a function, right, you allocate all the locally local variables. What happened is then when you return, right, all the local variable within that function will be deleted, right? So in the original code, what happened is they do a standard normally allocated array. I mean double, and then they would just reference it here, right? I think that's the original code. Well, what happened is you literally go in and once you return it, right, it returned the address, but the locally allocated variable is already destroyed, right? Because it leaves the function. So that means when you return it, you try to read that memory, it would not exist because there's nothing in it. It's already destroyed. So what I do is instead I allocated, I make a double pointer within a data member, okay? And then what I do is I allocate it in here. And then I would just return that. So then this one is, because it's manually allocated, it will not be deleted until I explicitly say delete, right? So you can see that because you say it's a memory leak in line 49, that means I create a new right here, but I never deleted. As I said, it's preserved the thing. So to do that, again, you go here and you just delete the point, right? You call it in the destructor because it's some data member, you can call the destructor just fine. So you can delete total area. And there you go. That's how you fix that part. So you go to the next one. Okay, 49 again, skip that one. And then you go to line 33. This is where you ask your question. Sorry, what's your name? Jin? Yeah, okay. Yeah, Jin. What he just mentioned, why do I not delete the points? Well, go to line 33. You see, right here, right? It probably have a new right here, but we never delete it. So for every house that we want to delete, we just have to manually go through all the houses. So in I equals 0, I less than vertices, I think equal to 2. Do that. I plus plus or plus plus I, whatever you choose. And then you can do delete. Because this one, you don't, it's each element in the array. You don't have to use the square bracket. You only have to use the square bracket when you delete the array itself. Okay. So, and sorry, I'm ironically did it. Points. So that looks like all the error. This last one is just repeated. So make. There you go. And that's how you fix the whole LE1. So does anyone have a question for me? Does this make sense? Like, do you see the power of GDB? You can investigate the problem immediately, and then you can see exactly what the problem is. Now, of course, this is a more sanitized version. Of course, in real life, when I actually debug something that I don't know, it will take some time. But for this, you can see that instead of having just a vague seg fault, right? Like most class, your lower class used to have, you now have the tools you need to debug memory errors and GDB, right? So you can print things without having to do cout. You can do anything without having to go through and recompile it again. Right? You can inspect the thing as it runs. So, and once you're hands-on, I hope that after this you play around with it and you should be good. And I will end the recording and I will test it in a bit. So let me end the recording. So see ya.
Stop.